So here we'll look at how we're going to apply the counting methods that we learned in the last chapter mixed in here with probability. So a student's choosing two books off a shelf, and we're trying to see what's the probability that they are both math. So we need to keep in mind the definition of probability, which is the number of favorable outcomes divided by the total number of outcomes. So here we look at how many ways can she choose two books that are both math. So I'm going to apply the formula from the last chapter, which is 5C2. And we can see that this is in fact a combination situation because it doesn't matter that the order that they choose the two books, just that they're going to choose two. Now I've got to divide that by the total number of outcomes. So here we have a total of 9 books, and I'm going to choose 2 of them. So we can plug this into the calculator to get 10 over 36, trying to reduce to 5 over 18. Now probability can be expressed as a fraction, which we have here. We can also do a decimal or a percent. Now here we can see that we have a permutation situation because order is going to matter when we're talking about pin numbers. So again, if we keep in mind the definition of the number of favorable outcomes and the total number of outcomes, we'll find each of these and then divide them. So in terms of the favorable outcomes, we're trying to figure out how many 4-digit pin numbers we have such that the first number is greater than 7. So we see that there's only 2 choices for this. This has to be an 8 or a 9. Now it has to end in a 3. So there's only one choice for that. It has to be a 3. And it doesn't say anything else about the middle numbers. So it would be 10 choices for each of these. So that means that we have 200 pin numbers that are greater than 7 and end with a 3. Now for the total number of outcomes. How many total pin numbers are there? Well, it says that the first number can begin with any digit except 0. So that means I have 9 choices for this. Well, the remaining digits can be any of the other 10 digits that we have. So 10, 10, and 10. So it's a total of 9,000 pin numbers available. So in terms of probability, I'm going to divide my favorable by my total and reduce that to 2 over 90.